Identifying ionic bonding. In this example problem, it says which compounds are not considered ionic. So remember, ionic bonds usually happen between metals and nonmetals, so that's a clue, but based mostly on their electronegativities. So we have to remember that's because they're based on electronegativities, not necessarily the name metals or the name nonmetals. It's because of the electronegativities that ionic bonding happens. So we have to take a look at all these 5 compounds and decide which ones are ionic and which ones are not. So as we can see here, SO3, these are 2 nonmetals. S and O are both nonmetals, and so that means their electronegativities are not that far apart. And you can see that even when you look at the periodic table, S and O are very close to each other and one on top of the other, and their electronegativities are not very far apart. So A is out of the running. Li and F, though. Li is a metal and F is a nonmetal. Their electronegativities are very far apart. If you follow the periodic trend, you'll see that the electronegativity of F is much greater than Li. Has one of the greatest electronegativities, so B counts as an ionic bond. MgCl, Mg is magnesium and has a lower electronegativity, and it's metal, and it's going to give up its electrons to Cl, so that both Cl's, each one of them gets a negative charge so that they can fulfill their octet, and both of them are going to be ions, so that means they are a metal and nonmetal pair. Now we have CH4. Now these two and H2O, so water, H2O, C4, and what we have magnesium chloride and lithium fluoride here. These are different from these because C and H and O do not have electronegativities that are very far apart. Even though H is in the alkali metal group, it's not really a metal. It's usually found in a gaseous state, and so it's very easy to give up its electrons, but it's not very far away in terms of electronegativity from C or from O or from other nonmetals. So both of these do not count as ionic bonds because their electronegativities are not that far apart. So even though H is in group 1, is in alkali metals group, it is only because it has one valence electron, not necessarily because it has the same amount of electronegative energy as other metals.